What's up? I'm Vin, and today I want to show how to solve quadratic trig equations. So for the first question here, we're going to solve for theta. Theta is going to be between 0 and 2 pi, so we're doing this in radians. And here's the equation. Now with these, you could write it out separately, but this I honestly just think about in my head. I just think of this as something like 2x squared plus x minus 1 equals 0. So this is how I like to approach these, is just think of this as if it was just a quadratic equation. And to factor this, we're going to use the AC method. And what we mean by the AC method, well, the A term here is equal to positive 2. Our B term is equal to 1. That's the invisible coefficient of x. And our C term at the end is negative 1. So the AC term here is the product of 2 and negative 1. That's negative 2. And then our B term is 1. So what we have to think about are two numbers that have a product of negative 2 and a sum of positive 1. And the two numbers, if we think about it, are 2 and negative 1. If we multiply them, we get negative 2. If we add these, we get positive 1. So now what we do with this is we take this equation here and we're going to split up the middle term. So we're going to write this as 2 cosine squared theta. And instead of plus 1 cosine theta, we're going to have plus 2 cosine theta minus 1 cosine theta, or just minus cosine theta. And then we just tack on the minus 1 equals 0. So you could see that if we were to combine these two, it would bring us right back to this line. And now we're going to do factoring by grouping. So we look at the first two terms, and we're going to take out a 2 cosine theta. And on the inside, we're going to be left with cosine theta and then plus 1. If you ever want to check factoring, you could always distribute, and it's going to bring us right back to this. And now here, I want to take out a minus 1. And I'm doing this strategically because what I want to happen is I want the factor inside this parenthesis to match this factor here. So if we take out a negative 1, we're going to be left with cosine theta plus 1. And now from here, we could just factor this a bit more. We could express this as cosine theta plus 1 times, and then in the other parenthesis, we're going to have 2 cosine theta and then the minus 1. And now this is all equal to 0. So the first factor here we'll set equal to 0. We're going to have cosine theta plus 1 equals 0, and this gives us cosine theta equals negative 1. Now the trick to being able to do this part in your head is to think of the unit circle, and just know that on the unit circle, cosine represents the x value. So what I'm really asking myself is, when is the x value equal to negative 1 on the unit circle? And that's going to be right here at this location here. And to get here from standard position, we have to spin pi radians. So what that tells us, first off here, we have theta equals pi radians, which is definitely between 0 and 2 pi. So now for the next part, what we could do is we have 2 cosine theta minus 1 is equal to 0. And from here, what we're going to do is we're going to add 1 to both sides. And we have 2 cosine theta equals 1. And then we can rearrange this to cosine theta equals 1/2. And this is after we divide both sides by 2. So now what we have here, we have cosine theta equals 1/2. And for this, we have to think of the 4 quadrants. So we write out our ASTC. Cosine is positive in quadrants 1 and 4. So since we have cosine theta equals positive 1/2, that tells me to focus on quadrants 1 and 4. And then the next thing I would find here is our reference angle. So the next thing I'm thinking about is cosine of which angle is equal to 1/2. Well, in degrees, it would be 60 degrees. But in radians, we express that as pi over 3 radians. So our reference angle is pi over 3 radians. So now we have theta equals pi over 3. But remember, that's our quadrant 1 solution. We also have a solution in quadrant 4. So now we have to use this concept of a reference angle. If it helps you to think in degrees and then write your answer in radians, you could also do that. So just know our reference angle is pi over 3 radians, or 60 degrees. So we could think 360 minus the reference angle tells us our quadrant 4 angle, which is 300 degrees. And if we want to express that in radians, we could just see here, to get from 60 to 300, it's times 5. So we could do pi over 3 times 5, and that's the same thing as 5 pi over 3. So this is just the thought process here. So these would be another set of angles here that would give us a solution to the original quadratic equation. But now let's write our answer out formally in order. So our first solution, the least value would be pi over 3, which is equivalent to 60 degrees. Pi radians would match up with 180 degrees, and then 5 pi over 3 would match up with 300 degrees. But here's our 3 solutions to the quadratic equation that we started with. So question 2, this is the next type of quadratic equation you could get. So a common mistake here is that when students try to solve this, they'll start by adding 3 to both sides, and you'll get tangent squared equals 3. But then they make this mistake. They do the square root of both sides, and they just say something like this: tangent theta equals just the square root of 3. But you have to be careful. This is a very dangerous trap. You have to think here, the square root of x squared is equal to plus or minus x, not just x. So we have to include that plus or minus, and the reason being is the concept is that the square root of x squared is actually absolute value x. So here we have to tack on the plus or minus. So then the next thing I think about is, when is tangent equal to square root 3? And the mystery angle would be 60 degrees. So 60 degrees, but we're going to write our answer in radians. That corresponds to pi over 3 radians. So what I think about here now is we have two equations. We have tangent theta equals square root 3, and we have tangent theta equals negative square root 3. So we'll mix in this idea of the quadrants, but one thing to be mindful of here, for both of these equations we have the same reference angle. Our reference angle is going to be pi over 3 radians. But just know tangent theta is positive square root 3, gives us a solution in quadrant 1 and quadrant 3. And then this equation, tangent theta equals negative root 3, would tell us that the solution to the second equation would be in quadrants 2 and 4. So really what we're doing here is we're finding the 4 angles. They all have a reference angle of pi over 3, but we're finding the angle in all 4 quadrants with this reference angle. So we'll write out our final solution here. We have theta equals, and we'll write our quadrant 1 angle first. Our quadrant 1 angle is going to be equal to the reference angle. That's just pi over 3. So this is our quadrant 1 solution. Then we have our quadrant 2 solution, and the thought process for this, when you're finding the angle in the other quadrants, you have to use your reference angle. So in quadrant 2, it would be pi radians minus pi over 3. The concept is the same as in degrees, except in degrees we would say 180 degrees minus the reference angle. But 180 degrees is pi radians. So we have pi minus pi over 3, and that's the same thing as 2 pi over 3. So that would be our quadrant 2 solution. For our quadrant 3 solution, we would do 180 degrees plus the reference angle, or we would do pi radians plus the reference angle in radians. So we have pi plus pi over 3, and that would be equal to 4 pi over 3. And then the last solution here in quadrant 4 would be the same thing as going 360 degrees, or 2 pi radians, and then subtracting the reference angle pi over 3. And if we do this, I just think of this as 6 pi over 3 minus 1 pi over 3 would give us 5 pi over 3. So here's our 4 solutions to the second quadratic trig equation. So this last equation is so easy that it's difficult. Now for this one here, what we're going to do is we're going to factor this. And for this one, what I'm thinking of is I'm thinking of the quadratic equation if we had x squared minus x minus 6 equals 0. And this would factor to x minus 3, x plus 2 is equal to 0. So I just think of this in just quadratic form, and then that would tell me that this would factor to sine theta minus 3 times, and let's just make this a little bit darker, and then we would have sine theta plus 2 is equal to 0. So from this step, what we're going to do is we're going to set each factor equal to 0. So we have the first factor equal to 0, and this gives us sine theta equals 3. And then I'm not going to talk about this just yet. I'm going to do the same thing for the other, but this one we're going to have sine theta plus 2 equals 0, which would give us sine theta equals negative 2. Now, some background knowledge that you should be bringing into this specific topic is you should know what the graph of sine and cosine looks like. And how does that help you here? Well, if you think about the graph of sine, sine starts at the origin 0, 0, and it's going up and down like this in wave-like fashion. And the same thing in this direction here. But one very important detail of the sine and cosine graph is that the range of sine and cosine is it's going from -1 up to +1. So when I get equations like this, I look at this and say, all right, sine theta equals 3. Well, 3 is way up here, and that's at a height of this. And notice the sine curve is never going to reach that height. Okay, so sine theta equals 3. The second I see this, I look at that and I say that's going to go up too high. Okay, the sine curve is never going to reach this because the range, once again, put that thought process over here. The range is the sine curve goes from -1 to 1, and this is out of the range. So this one here is going to give us no solution. And the same thing with this. Sine theta equals -2 is going to be too low. If I was down here at -2, this sine curve is going to not reach this. This is going to bounce between 1 and -1, so it's never going to drop down to -2. So this one is too low, and that tells us if there's no angle theta where we'll ever reach these heights, that tells us that we have no solution to this particular quadratic trig equation.